My name is Santamaria. I am a developer advocate at Pulumi. We are an infrastructure as code company, but it's also my first time here at Pi Texas. How many other people here is your first time here at Pi Texas? Don't be shy, raise your hand nice and high. Isn't it exciting to be here? Y'all excited? Right. Are y'all awake after lunch? No, maybe not. All right, well, I'm just going to kind of get started here. We're going to be talking a little bit about building a scientific computing lab on public clouds. Now, how many people here have ever used a public cloud? All right. So we have some people who have, some people who haven't. Basically, my job right now is I get to teach people about public cloud, but I used to actually study real clouds. So there are clouds, and then there are clouds like the ones in the sky. My degree is actually in Earth and Atmospheric Science. How many people here do not have a degree in computer science? I promise you are not alone. So, I also have my degree in Earth and Atmospheric Science. I spent a lot of time actually doing science research on weather, and I did a lot of teaching about weather, and I will say the most intimidating thing is trying to get a live weather demo to a bunch of 8-year-olds. Just so that you know, that's probably the most intimidating thing to do. But I used to study those clouds that are up there, and now I study cloud computing. So I get to teach about those now. One thing that we're going to find out today, because I get to talk about science today instead of just cloud computing, is that communication is important. When it came to actual professional science, one of the most important things that you need to be able to do is share what you've learned in a way that's understandable to other people, that they can repeat that without necessarily talking to you and get the same result. So, that being said, now that I'm no longer a scientist exactly, we can start talking about citizen science. It's lovely to get a chance to explore all of these data sets yourself. And there's a lot you can do on your own. However, there's some stuff you can't actually do because you don't have the same tools at your disposal. Generally, science data analysis is extremely hardware intensive. Most big research organizations have their own computing. They have people who run this for you. They have people who build it for you and set it all up. Unfortunately, that kind of hardware is expensive. So, for the average person trying to do some citizen science, it's too expensive to run on your own. In addition, if you're trying to run it locally on your machine, it takes a really long time. Now, I don't know about all of you, but I generally don't have a ton of time outside of work to sit and wait for a data set to run. Does anybody here have that time? And if so, tell me your secrets. How you are able to do that outside of work. Unfortunately, I'm not. I don't know about anybody else. The other thing, though, is that because we are not sure what other citizen scientists have available, it's really hard to repeat it locally on your machine. I mean, we all know the, hey, it works on my machine, right? How many people have said that? I've definitely said that before. But generally, when it comes to actual citizen science, you do run into that case where you say it works on your machine, but it's really hard to replicate on someone else's. So, how do we solve that? You might be able to guess. Anybody have a guess?
Public clouds.
Public cloud, that's right. Yay, cloud computing. So, the wonderful thing about the cloud is that there's a lot of options out there. It gives us the ability to do a lot of hardware-intensive stuff and make that more accessible to the average person. There is a slight problem though. Does anybody know what all these are? Can anybody name every single one of those? I can't, just so that you know. And I do this all day long. There's almost too many options, and nothing makes sense. Now, some clouds are really great at naming things in reasonable ways. Google Cloud does BigQuery. What does BigQuery do? Query data, yes! Some clouds do great at naming things, namely AWS. It's notorious for code names on all of its products. There is a lovely video out there, if you've ever seen Forrest Brazil's video, where he does a music video trying to name every single AWS product in about 2 minutes. It is a great video, please go watch it. You should check that out. And that's just some things that all of these cloud systems have. This is only the data stuff, by the way. There's hundreds of thousands of other products on each of these catalogs, and it's so much to try to understand. If you're looking for Apache Beam, which is something that you actually use a lot in data science, it's not called Apache Beam on every single cloud. In fact, every cloud has a different name for it. Dataflow for GCP, Kinesis Data Analytics for AWS. I honestly don't know what it is on Azure, and I should, but you get the idea. So this is a little bit of a problem. How do we solve this? Well, this is why infrastructure as code is extremely useful, especially for citizen science. Part of it is that you can actually go look at the API and start to understand, what are these products? What do they do? Oh hey, that one looks like this one. Wait a minute, it is the same thing, just renamed a different way. INC ensures that you have infrastructure that is repeatable, reusable, and replicable. Meaning, you yourself can always repeat and bring up the same infrastructure every single time and get the same result. You can reuse it wherever you are, and you can ensure that someone else you work with can actually replicate what you're doing, which is really great when you're doing citizen science and data analysis. Now, you can also move from cloud to cloud as needed. Should you realize, for example, that you've kind of gone over your free tier on one cloud, you can just hop over to a free tier on another one. Shh, I didn't actually say that. If you actually work at AWS, don't be upset with me. So, there are quite a few options out there for actually doing infrastructure as code. Today's demo is going to use Pulumi. I'm sorry, it's because I work there and that's what I know. It's also open source, but there are a lot of other options out there. There's Terraform. Each of the cloud providers have their own SDK, and you can actually do all of this with Python, which is the fun part. The important thing to understand is that using SDKs and hitting these APIs with infrastructure as code ensures that, again, it's repeatable, reusable, and a replicable experience for other citizen scientists. One of the harder things about working with cloud computing is deciphering that massive catalog. How do you decide what to use? It's not always a great idea to basically rent a VM and just run your code on it. That's expensive. You're going to pay a lot of money for it. All of that storage takes a lot of power and therefore a lot of money. So there's a lot of other options and optimizations you can do to take advantage of each cloud's strengths. Today, we're going to use GCP just because, one, I like it, two, the names actually make sense, so when we talk about it, it's going to make sense to everybody. And also, generally, it's actually pretty good for data analysis, so we'll be using that today. We are going to make some compromises on choice, though, because I want this to be accessible to everyone. We will not be using Dataflow or Apache Beam. I'm just going to be running a serverless function, and we're going to take a look at some data from there. Again, repeatable, reusable, replicable, and understandable for everyone to use. But there's one more thing about citizen science that you need. It's great if you have all this computing power and you know what code you're going to run and all that, but what are we missing? Data, that's right. So, where can you get your data? One of the lovely things about all of these various public clouds is that they've actually uploaded a lot of the public data sets from various agencies, including the National Oceanic and Atmospheric Administration, which is NOAA, the National Weather Service, and also Sphere weather data. So they pull all that in. You no longer have to pay for all of that storage, which is actually pretty fantastic. They host them for free, so you can analyze the data yourself. You don't pay for ingress and egress, all of these various things that you typically have to pay for with infrastructure. So, we're going to take advantage of that today. But, what question are we solving today? Well, March 25th, generally in Austin, Texas. How many people were following the news over the past 2 weeks? I see like 3 hands. Y'all, come on. All right. What typically happens on March 25th in Austin? It's weather related. I'm not talking basketball. Hail, that's right. I don't know if anybody saw it, but there's like, it's all over Reddit, all over the news. March 25th. Go cover your car. Quick, put it in a garage. I mean, yesterday was pretty sunny if you ask me. But we're going to take a look and see, is it true that March 25th is historically the most likely chance for hail? And with that being said, let's go look at some code. Okay, can everybody in the back see that?
Yes.
Yes, I see thumbs up, so we are in good shape. So let's take a look at what we're taking a look at here. Because I can't do this without actually looking over my shoulder. I'm going to look with all of you. So let's just scroll up a little bit. Come back. Here we go. Hey, look. Okay, so we're doing a little bit of importing here. Mainly the big thing is you can take a look at the secrets in the importing string. That's just mostly for line 10, which is giving me some random string that I'm appending to my job. The reason we do that is because otherwise you're going to get collisions when you push stuff up if there's already code running there. So that's just something to keep in mind. Random strings are helpful for naming to ensure that when you actually run all of this regularly, you never actually overwrite something you already have. This is something that you see pretty commonly in infrastructure as code. Now this line 7 is actually pulling in my little SQL query. There we go. Oh, it's not highlighted anymore. I like to put my SQL query in a different file just because it's a little bit easier for me to modify and keep under source control. So you'll get a chance to see that. Generally what we're doing on this round is we are pulling from the severe weather data set. We are pulling every year from 1950 on forward. And we're going to run against that and just look for the event date that it started. Is it actually a hail event? And did it happen here in Travis County? So those are our 3 big things that we're actually pulling down. And did it happen in March? Because we're going to narrow this all down. And now we get to the actual infrastructure. Again, this is all written in Python, so it should be fairly simple to read in comparison to other languages. I've been stuck in TypeScript lately, so I'm much happier being back in Python all over again. But a couple things to keep in mind when we actually take a look at any infrastructure as code is that you are looking at, in this case, a declarative piece of code. I like to call it desired state. We're basically passing this up to the cloud and saying, hey, hit this API and give me exactly what I've asked for. So in this case, we've got a bucket, which is storage, a bucket object, which is just the file that's in storage. We have another storage bucket. The reason we have 2 is one has code, that's why it's called code bucket. And then I have my data set, which is what? My data, that's right. Okay, just making sure y'all are awake. We have our actual BigQuery data set here. Again, this is just a little test data set that I have just to store the data that I'm actually going to be querying, which will then pull out to use for a cloud function. That's why it's just called foo and bar. Then we have 2 jobs. The jobs themselves are the important thing for the actual query. The first one is a query job, because if you look on line 47, yes, I can see that upside down. If you look at line 47, what does it say? Query, that means it's a query job. The next one down, and you can see we actually have that secure storage data. The next one down is our export job. And the export job just takes that data that we were actually able to run from the query from the table and dumps it in my storage bucket for just a minute while my cloud function actually is going to run and pull that data out. And then it comes out as a CSV, because we're gonna also be using pandas, like the last speaker, who brought that up in the very first part, so I guess he didn't really use it in the end. But it's there as well. And then we have our function to analyze some data. You'll note that I'm running it on Python 3.9, and we are here in the central region for GCP. So just a couple of little things here. This storage URL is the important part that tells us where the data is going to be living. And okay, one more thing about infrastructure just to know is that unlike running it on your local machine, you have to have permissions. So you have to have a little system that says, hey, this user is actually allowed to do what it's actually doing. If you don't do this, someone's going to be able to hack into your entire system and do everything that they want to do. So maybe that part's kind of important. Just a little bit. And at the end, we're actually going to see, when we run the code, we'll get a chance to actually see the variables. Let's go take a look at the app real quick. Again, I decided not to, can you all read that in the back?
Bigger.
Bigger? Okay, hold on. I'm gonna put the mic down. Better? Excellent. All right, so this is actually a fairly small analysis. I'm not going through a big one because it's going to take too much time, unfortunately, to actually run it. But we are just going to go through, pull in our data, and we're going to just grab the CSV, do a little bit of parsing on there, get my date time in the right format there on line 13. We're going to append it all to one data frame, and then we're going to actually plot it starting on line 20. And scroll down. And one thing to note, they don't really explain this about cloud functions. It's running Flask in the background if you're running Python. So even though I'm not actually importing this, and if you go actually run the code yourself on your local machine and try to do it yourself, you'll see that I'm not actually installing Flask in the requirements. So that's only because it's already there on Cloud Functions, and I'm not really sure they really documented that. But all that being said, y'all ready to see how this works? Woo-hoo. All right, pray to the demo gods, because I'm doing this live. I have not run anything. Pulumi up. Here we go. Maybe. Here. No, that's not the error. Hey, Pulumi, what are you doing? Oh, I know what I did. Hold on. Here we are. How many people just kind of go up and hit this? No action taken. What are you doing, Pulumi? For some reason, it's deciding not to run. Let me figure out what on earth it's doing. Normally, what this would actually do is show you all kinds of level information. I wonder if I've actually run it in this one specific one. But let me run it locally. Oh, I know why. Because we're not in the right directory. All right. Now let's try running Pulumi up. Actually, we're going to do a pipenv shell real quick. I am running pipenv. Please don't yell at me if you have issues with pipenv. We can talk about it later. All right. Now we're getting a preview. And why is it all the way stuck up there? Hello. I don't know why it's lovingly doing that. We're going to make it its own window. Maybe. There we go. All right, so here we go. Now we're getting what we need to see here. Let's make this a little bit bigger. Hello. There we go. Okay, so what this is doing is it's running a live update. It gives me a preview first. This This is important whenever you're doing any kind of infrastructure as code. You need to be able to see what it's about to do to your environment before it actually runs. So in this case, we are seeing all of these various things in a very, very, very poor format. But we'll see that we actually have our data set, our bucket, our table, the bucket object, the function member, and the jobs. So we can actually look at details, but I'm just going to hit yes, and we're going to see that it's going to actually deploy. Now this does take a little bit, and I don't know why this isn't scrolling. There we go. You know, we do have the JetBrains people here. Maybe I need to have a discussion with them about what this is doing when it's in a weird terminal function like this. Because normally it shows me a nice little table that shows everything actually deploying. But we're gonna run with it, because you know, live demo. How y'all doing? Doing good? This function actually does take a little bit of time to deploy here. But actually, I wonder if we can see it. We're gonna go see if we can see what it's doing in the Cloud Console. There it is. So you can actually see my function is getting made up there at the top. Let me make that a little bit bigger. All right. My computer doesn't like me today, clearly. But it's running. We have our code. Where did my terminal go? There it is. Still creating. While this is creating, anybody have any questions for me? Commentary?
Is this like the Terraform
Is this like the Terraforms?
process?
Sort of, it's kind of like the Terraform process. The big difference between Pulumi and Terraform is that we use development languages, programming languages. So if you're familiar with Terraform, we just did a Pulumi preview. It's kind of like a Terraform plan, where it just kind of checks and sees what's out there. And then we're running Pulumi up, which is whatever Terraform's like apply it. I guess it's Terraform apply? Yes, I think that's what it's called. Anyway, so yeah. Well, any other questions while we're waiting for this thing to decide to finish running?
Yeah,
If you run this more than once, it's going to create like multiple resources, or it's going to update those resources?
Great question. The question was, if we run this more than once, is it going to recreate all of the resources, multiple resources, or just update the ones that are in place, right? It's going to update the ones that are in place. That's actually the next part of the demo. No, so generally infrastructure as code, this is one of the reasons why you use it, is that it doesn't actually try to reinstall everything. It does actually make sure that you don't reapply everything, so you're not rebuilding everything. The reason that's really important is that it takes less time, therefore you're spending less money, which is a good thing, and you also don't really overdo it. All right. How many people think it's the 25th? How many people think it's the 27th? The 4th? Take a look at that. That right there, friends, is the 25th of March. Since 1950, we have had, what is that, over 50 hail events on March 25th. Now that also includes, because you have to remember, this is reports of hail. So that includes multiple reports on some days. So next year, March 25th comes around, maybe consider taking your car to the garage. We're covering it with pool noodles or whatever else we're doing today. So, go do some science. The very first link that you see up there will have my GitHub repo, so if you want to go do this yourself, you certainly can. Thank you all so much for listening. Thank you for putting up with my technical difficulties. And I'd love to take any questions y'all have.